Welcome you all for this video. So this is about the wireless and cellular communication course bearing the US course code as 18AC81 and the topic name is GSM and TDMA technology. So under this you are going to learn about the GSM identities. So what is GSM identities? So the MS has the mobile station ISDN number that is MSIDN that uniquely identify the mobile telephone subscription in the PSTN numbering plan. So it is therefore a dialable number and it is linked to the home location registers. So the international mobile subscriber identity is a unique identity allocated to each subscriber by the wireless service operator, and it is stored in the subscriber SIM. Okay. Next it is the SIM is going to be the subscriber unique identity mobile number. That is the SIM, the IMSIE number is also stored in the home location register as well as the visitor location register. So temporary mobile subscriber identity, that is known as the TMSI. So the number is used by the GSM network to protect the subscriber privacy over the air interface. So the wireless networks assigns a TMSI to the MS, and the TMSI number only has the local significance within the particular mobile service center or the visitor location register. So next one is the network numbering plans. So the GSM uses both the location area identity, that is LAI numbers, and the cell global identity, that is CGI numbers. So LAI is used for mobile station paging and the location updating, and the CGI is used for cell identification with the location area. So within the wireless network itself, the network elements will have identity numbers or addresses that are necessary to facilitate the correct operation of the system. For example, the base station identity codes, that is known as the BSIC, and the mobile global titles is known as the MGT. So that uniquely identify the network switching system elements with a particular operator network. So next one is the mobile station roaming number, MSRN. So which is the GSM used by the GSM system during the call setup operation. So this operation you are able to see on the screen, that is the call setup using MSRN. So figure shows under step 1 what it does, that is a gateway mobile switching center receives a signaling message, that is initial address message from the PSTN about the incoming call for a particular MSIDN number. In the step 2 what it does, the GSM SSC sends the signaling message and send the routing information to the HLR where the subscriber data for the particular MSIDN is stored. In step 3 the HLR uses the MSIDN to find the subscriber data in the database. So the VLR, that is a visitor location register, addresses the corresponding to the subscriber location and the IMSIE for the subscriber, and it is retrieved from the HLR database. Step 4, the HLR sends the provide the roaming number and message to the MSSC or the VLR using the VLR address as the destination and IMSIE to the identity of the mobile subscriber. Step 5 is going to be the VLR asks the mobile switching center to seize the idle mobile station roaming number from its available pool of numbers and also associated with the IMSI number received from the HLR. So number 6 is going to be a mobile station center to the visiting location register, sends the MSRN back to the HLR, and the step 7 is going to be HLR sends the MSRN back to the gateway mobile switching center. So what is the step 8? Step 8 is going to be uses the MSRN route the correct MSSC. Now the serving MSSC receives the signaling message, initial address message for the incoming all identified by the MSRN value. So the MSSC analyze the incoming digits associated with the IMSI. So that corresponds to the subscriber MSRN number and is realized the mode of available for the other calls. So you are able to see on the screen what MSRN is going to be. It is going to have CC plus NDC plus SN. So CC stands for country code, NDC stands for National Destination Code, and SN stands for subscriber number. So, next is the GSM system operation, that is when the traffic cases. So, what it is, how it is going to handle. So, here it is going to be first initially it is going to be under call setup phase. Under call setup phase there are 11 processes. So, what are 11 processes? That is interrogation, radio resource connection establishment, service request, authentication, ciphering mode, setting IMI number check, TMSI allocation, call initiation, assignment of a traffic channel, user altering signaling, and the call accepted signaling. In the interrogation phase, what it does? For the interrogation operation, one notes that initial address message, that is IAM message, course from the outside of the GSM network using ISUP or TUP protocols. So, in vendor's system, the GMSC can send the request to the flexible numbering register, that is known as the FNR system mode, before sending into the home location register. For security reasons, the subscriber data can be simultaneously stored and updated by the to and fro HLRs. So, the two GSM modes uses the non-MAP protocol to communicate with each other. So, first deal with interrogation done. So, next one is the radio resource connection management. So, first interrogation phase you are able to see what is that. First it is going to send that is the initial address message to the PST into the GMSC. GMSC will receive the information, that is to send the roaming information. It is going to contact the HLR is going to contact the MSC and receives the roaming number and send back to the mobile switching center. So, next one come to the interrogation radio resource connection establishment. So, the graphic of the radio resource connection establishment process shows the detailed steps required for the radio resource connection establishment. So, you are able to see here there are 4 parameters come into picture. One is the mobile station, the other one is the BTS, the third one is the BSC, and the other one is the MSC. What it does, first MSC will initiate the call setup process by sending the layer 3 paging message to the appropriate BSC. So, the paging message will contain the subscriber IMSI number, so that the BSC can be calculate the correct paging group use. So, next what it does, so it is going to identify the what is that location identity, that is LAIC provided by the MSC to the BSC. So, the BSC receives the paging message, typically translate the LAI to a cell global identity, that is what CGI number to the information was not provided by the paging message. Next, so the BSC sends the paging command to the appropriate BTS. So, this message will contain the following IMSI or TMSI, temporary or the international identification. So, the paging group and the channel number. So, the channel number will contain enough information to indicate the channel type and the time slot. So, for this reason the channel type is a downlink common control channel. For GSM system, the paging group is determined by the subscriber IMSI and the other information defined in the BSC when the mobile station has received the system and knows its paging group. Next one is the BTS sends the paging request message to the MS. This message is sent to the paging channel. So, there are several different types of paging request possible depending upon the IMSI and or the TMSI. So, the TMSI temporary mobile identification, subscriber identification numbers are used to instead of IMSI. So, up to the 4 MS can be paged in one paging system. So, when the MS responds to the paging request by sending the channel request to the BTS, you are able to this in the figure, that is the second signal. So, the request, so next one is the request to send the priority if the experiencing, you are able to see in this diagram. So, that is the next is to when the BTS detects the access burst, when BTS detects the access burst, so it sends the channel required to the BSSC. Okay, you are able to see here BSSC. Next is the BSSC examines the information contained within the channel required. So, the BSC determines what channel to use and sends a channel activation to the BTS that contains the following, that is mobile station and the base station power, timing advance, that is TA, and DTX status and the data status and the reason for the allocation and complete description of the channel as shown in the figure. So, the BTS activates this channel, then sends the channel activation acknowledgement message back to the base station center. So, here in this diagram, that is the GSM channel description message, you are able to see that is H is equal to 0 and H is equal to 1. When H is equal to 0, it is going to be used for the single carrier frequency operation, that is no hopping, and the multiple carrier operation it is going to be H is equal to 1. So, which is going to use the audio frequency, that is the AFFCN signal in case of single carrier. They going for the offset because each and every carrier is going to have the different frequencies, they are going to use for the offset. So, that is known as the one more parameter you are able to see, it is on the screen, that is the access grant channel, which is instruct the mobile station to switch allocated signaling channel. So, next is the service request, that is ARFCN is nothing but absolute radio frequency channel, and MAIO is nothing but a mobile allocation index offset. So, TS stands for timing advance, HSN stands for the hopping sequence number. So, next we move on to the service request. You are able to see under this, and the service request phase occurs as soon as the mobile station has turned new channel assigned to it. So, at this time the layer 2 message is known as the set of asynchronous balanced mode, that is SJBIT, is sent to the MS to BTS. So, in this layer 2 message contains the layer 3 message information, that is field of layer 2 message contains the paging response message, and the BTS sends back to the MS to a layer 2 message as an unnumbered acknowledge, that is UA, that is can be transmit. So, it is not bother about it. So, that is a frame that contains the original paging message. So, this operation prevents the chance of occurrence of two MS accessing the same channel simultaneously. So, the paging response to the message from MS contains the information about the MS identity and the ciphering sequence number. So, MS class mark, when the paging response arrives at the BTS, it is forwarded to the BSC in an establishment indication message. So, this message causes the BSC to activate the radio connection quality supervision and initiate the power control algorithm for dynamic control of the MS output power level. So, the paging response message from the MS is to be eventually delivered to the MSC. Therefore, the BSC sends it on the MSC a connection request after the it adds the CGI, global cell global identification number. So, next stands for the authentication. So, this authentication service, which is the GSM authentication which operations, that is 128-bit random number, and it is going to use the cipher key sequence number, and signed response data request and indication are used to pass the layer 3 message A, and it is sent to the mobile switching center or the visitor location register. If the timer expires in the second time, the radio resources are released, and if authentication is unsuccessful, the GSM initiates the procedure to identify the MS, related MS. So, MS is based on the send the message, and if IMSI is unknown in the visitor location register or the that is the mobile network is when it is not a personal location public location mobile network, when it is not allowed. So, it is going to be resend the message. So, this is going to be a authentication procedure between the BTS and the MS. between the BTS and MS, and as well as the BSSC and the MSSC. So, next is the GSM ciphering operation. So, you are able to see the ciphering text is going to be process is going to be for authentication. If, as I mentioned, it is going to be if it is not authenticated, it is going to search for the authenticated mobile station. So, what it does in the ciphering mode? So, if the authentication process is successful, the next step is to call the setup process is initiated. The process of ciphering mode setting, and that is MSSC or VLR sends the ciphering mode command to BSSC. This BSS MAP message contains the value of KC, that is the value of the value is forwarded to the BTS within the encryption command message. So, the BTS stores the value of KC and sends the non-ciphered ciphering mode command message to the MS. So, the MS insert the KC and the TDA frame number to the another authentication algorithm, that is A5, which is been creates a ciphering sequence that is added to the message that is to be sent, and this ciphering mode complete message is sent to the BTS. So, the BTS upon the receipt and the correct deciphering of this message sends the transparently to the MSSC via the data indication and frame from BTS to BSSC. So, the ciphering key sequence number is used by the GSM system to reduce the number of steps required for the call setup. So, next it is going to check for the IMI check. So, in IMI check, it is going to be check it for the IMI number is to be checked. So, under this process, the MSSC VLR sends the identity request to the mobile station